Okay. And I'm going to share another screen. So I'm gonna stop sharing this and go for the whole desktop. The whole desktop is here. Okay, close this. Excellent. So I'm going to start slowly because I'm not sure that everyone got the message concerning the fact that we were starting at 8. But I'm going to start anyway so that we can have time to breathe among the sessions and that you are not overwhelmed with all these hours of connection. So in the menu today we have the last part of the data sharding with Mongo. I remember that I asked you to prepare the whole flow of the exercise until the hash strategy, which is where we stopped in the last session. So today we're going to see how to create new shards and see how chunks are go from one shard to the others. And the last strategy proposed by Mongo in order to shard our data. And that will be the example that we will finish regarding data fragmentation, which has been an important part of the big data sessions that we have had in the previous weeks. Remember, it's really so that you can touch and that you can see how things work in a more realistic manner, and particularly considering that this part is addressing a view on large scale, how to deal with large scale using different tools. And then we will go to a new aspect of data, which is data analytics. And we will start playing with other tools that will let you perform more analytical processing of the data. And at the end of today's morning, I will introduce a project that we propose to you. This will be part of the grade, and so that you can alone produce some results regarding a project. You will see it's interesting, it's very simple, but still it will wrap up the things that we have addressed during these sessions. Okay, so let's start with the sharding part. So as we said, this is my Facebook, but no problem. I'm going to share the other serious part. Okay, so remember that for performing this final part of the data lab on sharding, we need to connect to Docker Play, which you have, for which you already have your account. You need a new instance, and once you have this new instance, you go to the specification of the hands-on, which is in GitHub. You have the address on the slides that I used in the previous session. And what I required is that you redo the different examples that we ran during the last session. Just to remind you what must be stored in your minds with regards to this data lab. First of all, we learned how to configure a cluster, a Mongo cluster. So what we saw last time is that in order to have this cluster, the elements that any cluster will have are local Mongo servers, which are called shards. Then another server that needs to have a global view of these different shards that will participate in the cluster. And this is the query router, okay? As we saw in the example of HDFS and during the theory part, you need to have an index that says where are the data, who is who, and who stores which data. And this is the config server that has the knowledge, the abstract knowledge of the content of the different shards. So the query router will cooperate with this config server in order to know which data are sharded across the different shards that compose the cluster. So this is the back end of the cluster, and then in order applications or users to access to this cluster, we need a driver that gives us the entry. It's an entry point to the cluster. So in Mongo, it is called the CLI, and it interacts with the query router that will give them access to the different elements of the cluster. So we learned for the time being to create a CLI, a query router, and one shard. Okay, for the time being, we only have one shard server. And remember that inside the shard server, we have different pieces of a data collection, which are called the chunks. Okay, and in order to determine how, given a global collection, how to fragment it into chunks, we have visited two strategies. For every strategy, what we need is to go and have a look to the structure of the documents and decide, choose an attribute of this document that will serve as a reference in order to fragment the collection. And this attribute is called the sharding key, okay? So for any strategy, what we need is to choose a sharding key and then tell Mongo whether we are going to use an interval strategy. This would mean that the fragments are sharded with respect to some intervals of the values of the sharding key, okay? Or we can have the other strategy, which is using a hash function for applied to the values of the sharding key in order to determine the number of chunks and how to divide the collection. So this is what we have seen until now. Now, what is the strategy that must be used in Mongo for doing this? Is what we do first is we uploaded a general collection that we declared that it was going to be sharded at the level of the query router. So this was the first part that we did here, okay? And once we have this, data collection, then we applied the two techniques that we saw last time. The first technique was we copied the collection into a collection called cities1, and then we use cities1 in order to shard with the interval strategy. And then we did a similar operation, but by creating another copy, which is called cities, and then we applied to this the second technique, which is hash. And remember that in order to observe the previous status of the shard and then the new status once the chunks are created, we use this function status in order to see and observe the result. So if we go back to the last execution of the hash-based strategy, and this is my result of the of status, which is here. You can see here that I perform my function status. So what we see, remember, is first of all, it provides the characteristics of the shard, of the server that is hosting the different fragments of my data collections. So we called it shard1. And then what we have seen for the time being is that no balancing has been done because there is only one shard. So you cannot move the chunks across the shards because we have only one shard. And another important thing is that remember that our data collection is stored in my DB database, and this my DB database is the primary copy, okay? Then we will see that we can have different copies. And it's again in shard1. And then what we did is that we applied the hash function and we ended up with several shards. So we have in fact four, well, with several chunks. We have 4 of them with respect to the sharding key, and we chose state, the attribute state of cities in order to apply the hash function and fragment the data collections, and we ended up with these 4 chunks. So this is what we did last time, okay? So first, before we go on, do you have questions? Remember that you can always use either the chat, Slack, or you can open your mics and ask. Feel free to do that.
Sorry, teacher, I just have one question about this sharding. The number of chunks, is it determined automatically by the system? Because yes, we have here four chunks, but we didn't choose how many chunks we want.
No, it is chosen by the system with respect to the distribution of the values. So the strategy of the system is to try to have chunks more or less of a similar size.
And the same thing with balancing, moving chunk across 2 or more shards. Is it done automatically? Yes, or
we will see in a minute that the load balancing is done automatically. Yes.
Okay, thank you.
Mm-hmm. Other questions? So if there are no other questions, thank you for your question, because this lets me go further to the new part, the one that we have to do today. So as I said, for the time being, we have only one shard. And this is interesting already because we have our different chunks, but then imagine that we suddenly put more data and want to across the fragments, and we do not have any space for that. So in fact, what the system will do is try to see whether it has new resources so that it can distribute the different data. So there are 2 criteria in order to distribute the data. One is to have as your classmate asked, you need to balance the weight of the different chunks across the shards that you have. And the second thing is that it will try to replicate in order to ensure availability. Okay, so this is done automatically, and this first can be easily seen if we create new shards. So what we are going to do is we are going to make our cluster grow in an horizontal manner by adding new shards. So we are going to create two shards, shard 2 and shard 3. Okay, so I'm going to do this on my remember that that's very important, that the one that has the right to add new shards to the cluster is who? Is the query router. Okay, so we declare to the query router that we are going to add two servers, two Mongo servers to the cluster, one called shard2 and the other one called shard3. And now what happens is that now the query router knows that it has three servers, and the idea is that it will start manipulating the different chunks in order to have a balanced organization of our data across the different resources that we added and that it has available for dealing with this. And again, how do we know what it did? Because this is done automatically by the system, so we can go and observe the new status of our situation. So let's analyze this. You can already see here that now we have three shards. So 3 Mongo servers added to the cluster with their identification. And now the balancer is activated. For the time being, it's not running. It hasn't done anything. It hasn't attempted to do anything for the time being. And we still have my DB as primary shard. And then let's have a look on how the chunks are distributed. Well, it says that in the database, my DB regarding the collection cities, remember that now we have two collections, two chunks regarding two collections, one for cities 1 and the other for cities 2. Okay, so with respect to cities 1, it says that it used the attribute state in order to chart. It has 3 chunks distributed across shard 1, shard 2, and shard 3. Okay, so it has 1 chunk in every shard, in each shard. And it keeps telling us that remember that for cities 1 we use intervals, so the intervals are declared here. It has 3 intervals, the one with the minimum value of state until the words, states starting with MA, then from MA to RI, and then from RI to those states that would be named with S, for example. Okay. So this regards the first data collection that we sharded with the interval strategy. But it says also that concerning cities 2, which is the second collection that we sharded using hash, the hash strategy, then look what is interesting. In this case, remember that we have 4 shards. So in this case, what it did is it stored two chunks on the first shard, and the other two on the on shard 1 and shard 2. Okay. And then it gives, of course, the details of the different chunks obtained by sharding the data collection. Okay, so as you can see, it for the first collection, it distributed this collection more or less, yes, homogeneously across the three charts, and then it ate resources. Okay, so for the second collection, what it decided is to have two of the chunks in the first one, and then it divided the next two on the other two remaining shards. And if we add new chunks or if we add new data, then it will start playing with the chunks and making them go back and forth. Interesting thing is that it does it automatically, so no administrator has to have a look on the details of the different chunks and make decisions, because now we have three shards and the collection is not very big, but you can imagine that if you have an important volume of data and you have many shards, then the decision becomes much more complex. And this is why Mongo has, and almost all NoSQL systems have these strategies implemented by default. Of course, it is possible if you have or you want to have an advanced use of the stores to configure the strategies differently. Okay? They will always be done automatically, but you can change the configuration according to your requirements. Okay, but this would be an administrator that would do this with respect to the loads that start coming from the use of the data. Okay. So, and now what we're going to do, and then we will see how we end up with the distribution. What we are going to see is that you can rely on the data that you have and on the characteristics of the data that you have in order to decide how to shard your data. But it is also interesting that if you have knowledge of some specific requirements from the application, then you can perform a more semantic strategy in order to shard your data. For example, consider the data here that are very related to the different states in the United States. Imagine that suddenly you decide that the data regarding Washington are more or less critical and that need special treatment, for example, access control, or they are queried less often. So you are going to you decide to separate this data that need particular treatment in a specific chunk, and then you other data concerning other states, you reorganize them differently, okay? So this would be the kind of intuition that you would apply in order to decide to use this sharding strategy. So what we are going to do is the following. We are going to say that data regarding California and regarding New York are going to be grouped together, and then the rest of the data concerning the other states will be grouped all together, okay? So we are going to have three shards. And note here that now you have a decision on how many shards you are going to use in order to distribute your data. In this case, we decided that we want three chunks, okay? So let's start doing this. So we are going to create this first, then this one regarding New York, and then the others. So we are tagging our fragments with these tags, CA, NY, and others. Okay, so that's what we have done here. Now we have the containers tagged with the labels, and now we are going to fill them. Okay, so we go to the database, my database, which is there where I have the first initial collection, and then I will do the following. I will create cities 3, so a first copy of it. This is something that, again, you have done in this data lab, but also in the first data lab, we are creating a copy of the initial collection, okay? And this is for pedagogic reasons, because we want to use all the time the data, and then we create a copy on this copy that we do the sharding, okay? This is to keep the original data collection available so that we can play with it. So we wait for a while so that it creates the copy. And then while it creates a copy, note the following. I'm going to really fragment my explicitly. So you see now you create your shards explicitly and you do not leave this to the system. So we are going to say that the first chunk will contain data where you have the minimum states. So those states, in this case, we have a string, so this will be states starting with A. From A to CA. Then we will have one that will contain only data where the value of the attribute state is CA. So we are creating a chunk devoted to California, okay? Then we create a new, between CA and New York, there should be more data. So we put them again on the chunk named by others. Then we create a chunk devoted to New York, and then the rest of the data, we put them again in others. Okay, so in this way, we have all the data of California in one chunk, all the data of New York in one chunk, and the rest, which are in between, and by the end, after New York until S, or I suppose that there is no Z in a name of a state, again in the chunk labeled as others. So this is very cool, because I'm going to do it step by step. So here I created my copy. I start creating my first chunk. So on the copy cities 3, I look for data from A to CA, and I put them in the chunk labeled as others. Then I create the one concerning California, which is the one that I wanted to separate. I create California. Then I create everything, I put everything between California and New York in the chunk others that I already had started to fill. And then finally, I create my chunk for all New York, and all the rest I put it again on others. And then I can see what do I have. So this is very cool because here I have again, it gives me the description um, of my cluster. Sorry, here. And then it says that I have created 3 tags, CA, NY, and others. Okay. Then it says that, okay, we are accepting charts. And then let's have a look to the distribution. So I have the distribution for my first chunks that I chunked using the interval strategy. I still have those regarding hash, and here I have the new ones. And the new ones are, if you have a look, are distributed only in server number 1 and in server number 3. In server number 1 that we named shard 1, it stored 3 chunks, and in server number 3 it stored 4 chunks. Okay, so and it has it reports the distribution of each of them. Okay, so it says that um, California is stored in shard 3, and with different elements. Okay, so we have CA in this first chart, then we have California to MA in chart 1, then on chart 3 we have New York, and so on and so forth, and then others is here with the remaining elements of the data. Okay. What else did I wanted to say? I think that that's it. So if you have a look here, you see in shard 3 we have 1, 2, 3, and 4 chunks. Okay. And in shard 1 we have 3. And we didn't use shard 2. Why? Because it already had, if you see in shard 2, we already have 2 chunks from the previous one. So it looking for a balance, it decided only to use shard 1 and shard 3. Okay, so all California is stored in shard 1, all New York is stored in shard 3, and the remaining ones, which are MA to New York, which do not belong neither to California nor to New York, are also stored in shard 3, and then neither California nor New York, so the remaining ones, they are stored in shard 1.
Excuse me.
Yes.
Does it have any difference for us to store our data in which shard?
No, I mean, for us, we will see the difference when we query the data, okay? Because when we query the data, if you have many queries regarding, for example, shard 1, then you have interest to be sure that you will not create a bottleneck in order to deal with all these queries, okay? So depending on the number of queries that will arrive to one or the other, the system will try to create copies and to distribute them along the cluster so that you have the impression that you are the only one accessing the data, even if others are also accessing the data, and that they are being used extensively. Okay, but this is the intelligence of the system, and the idea is that from the point of view of the one who is querying, this should be transparent. You should be able to query and to have good time performance, temporal performance in order to retrieve your data. And all the backend will configure itself in order to make sure that you have this impression.
Okay, thank you.
Okay. Now, if you are the administrator, then you will try to have a look on the loading, okay, on the number of queries that you have, and the only thing that you have to make sure is whether your distribution is being appropriate with respect to the requests that you are receiving. If not, then you might have the need to explicitly move chunks or create copies in the case of this tagging strategy. On the other strategies, the system will do this for you. Other questions?
Yes, please. I have a question. What is the difference between the first chunks and the others? Because in the first chunks you have the mean key, and I don't know really what does it mean.
In the first one, in the first strategy, we are only using the attribute state. Okay, so the attribute state at some point in the data lab we queried the data. Okay, and if you query the data and you ask for all the states available, in fact, what you will see is that they are distributed in well, they are strings, okay? So they can be organized with respect to the alphabetical order. So in the first strategy, you assume that the distribution of your data is more or less normal, okay? So it is interesting to define with respect to the alphabet, pieces of your data that will divide your data in a more or less balanced manner. Okay, so you will say from A to data regarding the states starting with A until some letter, I will create a piece. Then from that letter to some other letter and so on and so forth. So how do you determine the good sizes of the intervals? Well, you don't do this. The system goes and has a look on the distribution and determines which is the best way of fragmenting the data with respect to the interval, with respect to intervals, and so that you end up with chunks that are balanced, okay? I'm not sure that I was that clear for this.
Yes, it's okay, but
okay.
My question is on the database cities2.
In cities2, with respect
Yes.
to hash, now that was interval, we knew the values, okay? But let's think that in your database, in fact, you have more, a lot of data with a few data with M, and then no data until T, for example. So the distribution is not that normal, okay? So in that case, if you define intervals, you will end up with intervals with many data and with intervals with very few data. And this is not good for performance, okay? So in the hash strategy, what you will do is apply a hash function that will have the string as entry, and it will create a value, okay? And the values that it will create will be normalized, okay? And in that case, you will use the result of applying the hash function to your different values in order to choose the right sizes of your chunks.
Yes, okay, it's clear. Thank you.
Other questions? Now, the goodness, your questions are going right to the point. The problem here is how do you decide, first of all, which is the sharding key, so the attribute with respect to which you are going to fragment your data, and which is the best strategy to use in order to shard your data. Okay, so the decision-making problem is there. The answer is that you have a look to all the attributes of your document. You see the distribution of the values, and you are going to try to find out one that will be normal or a combination that will create a normal distribution, so that you can decide whether to use at least the first two, okay, interval or hash. For the third one, as I said, this depends on the application. So the application requirements will guide you with this. But at least the first two, you have to go and explore the data, explore it statistically in order to make your decision. Because of course, another strategy would be to test and error, no? So you try some attributes and some strategies that seem adequate, and then you see how you end up with the distribution. But now we have very few data, but if you really have important volumes of data, this costs a lot of resources. So you cannot do this like that, okay? More questions? Are we done with this? Okay, if there are no further questions, we are going to close this topic, and we are going to start a new one. So I'm going to close my browser for the time being, and I'm going to use some slides first. So at the very end of the NoSQL session, before the data labs, I announced some questions that could not be answered with querying in general, okay? NoSQL or relational or whatever. These type of questions cannot be answered using these solutions. For example, prediction queries, okay? The expected evolution of the market of electric vehicles, the expected active life of a manufacturing machine before its first breakdown, okay? Or classification questions. For example, giving a set of images of steel sheets, identify those that have wands in the central area. Okay, so you have to classify those that do not have wands from those that have wands. How do you do this? Which are the characteristics of clients willing to buy electric vehicles? So you have to create communities of clients according to their profiles, and then see which community might be interested in buying electric vehicles, for example. Assuming that you know which characteristic of a client buys electric vehicles, okay? Which anomalies cause fatal breakdown in a machine. Okay, so there you have to observe the anomalies coming up during the execution of a workshop, and then know also fatal breakdowns, and then according to this try to correlate these two events in order to determine groups of anomalies that might cause these problems. Okay, so all these, we cannot use a query language as the ones that we have been using for NoSQL and relational in order to answer. Okay, so this makes us start approaching other techniques. And in this lecture, I am going to consider that all the techniques that are used in order to answer this type of questions can be grouped under the umbrella of what today we call data science, okay? You will see in a minute that, in fact, data science is composed of different strategies coming from different sciences, and then it provides a methodology in order to address problems. But I'm going to use this umbrella to group all these things together. First of all, an important thing that will guide the solution of the problems, of the questions that I have enumerated before, these questions call for experimental data processing approaches. Okay, so we are going to run experiments using the data in order to try to answer these questions. And these questions will be, well, they can be considered queries, but in the jargon of data science, they are called research questions. Okay, so we are going to express research questions. Some of them will be simple and others will include hypotheses. And according to this, we are going to build experiments that will try to either answer more or less directly our research questions, or validate or contradict hypotheses that we might have stated. So we are going to see how do we design these experiments and how do we deal with them in a computational setting. So first of all, we are moving to a trend that has appeared in the last few years, which says that data is everything and everything is data, okay? So the idea is that through sensors, through different devices, it is possible to observe a phenomena that happened in reality, that these observations are digitalized, and once they are digitalized, they become data. And if you analyze them, you will produce new data, etc. So you are going to have this life cycle of data that will help you observe a phenomena and understand them, okay? And this is thanks to the trend that we know as big data, okay? Now, the other word that, concept that appears and that leads then to the emergence of data science is what we call datification. So the fact that we can transform any phenomenon into data is called datification, okay? So we datify phenomena. So this means rendering into data aspects of the world. Normally, many of them have been observed, but many of them have never been observed. Okay, so now we have this possibility, and this creates two opportunities. The first one is to have analytical knowledge of these phenomena, and the second one is that if we do that, we will have evidence-based decision making possibility. And what is particular about about today is that this can be done more or less by any person or any company, which before this was possible in specific experimental science, but this was done in labs by scientists, etc. And now anyone can have this approach. And then there are many sciences that have evolved and have been redefined in terms of this datification. And all these sciences have in common that they have as backbone data, okay? So they will be experimental sciences based on digital data, okay? So you have social data science, network sciences, digital humanities, computational sciences. So all these sciences are use data as backbones in order to run their experiments. And of course, there's data science that provides means to all these sciences to process the data and exploit them. Okay, so data collections as a backbone for conducting experiments. Experiment is a very important word here. They drive hypotheses that lead to valid conclusions, models, simulations, and understanding. When I say valid in quotes, it is because we never have a definite answer to our queries or to our hypotheses, okay? These answers are associated to have associated performance as assessment scores that will tell us how far or how performant are our answers with respect to reality, okay? So that's another important difference from the other type of queries that we have addressed in the previous part of the course. And the challenge is that we have to develop methodologies that include many different things. Since data is backbone and data are digital, so we need data management strategies in order to deal with all this data, okay? The first part of the course regarded this, okay? Strategies in order to deal at the back end of the systems, of the experiments with this data. Why do we need this? Because normally, in order to predict and in order to classify, we have to apply what we call greedy algorithms. These algorithms require a lot of computing power, a lot of memory, and a lot of storage support, okay? So these algorithms that require many computing resources in order to be run deal with data, and so this management has to come together in order that they work correctly. Nothing can be done if there are no programming models, okay? So we have seen in the previous lectures that normally you need large-scale architectures that provide us with important resources, but this means that we need the well-adapted programming models in order to do that, okay? So these ingredients must be tuned together in order to to run these experiments and expect obtaining answers to our questions. So, and there is where data science comes. Okay, so you have guessed that tuning all this in one experiment is a lot, okay? So we need methodologies in order to do that, and data science is there in order to start providing strategies on how to build and design these experiments. Okay, so just to have the vocabulary, common vocabulary for us, data science is the representation of complex systems by rich data and opens the possibility to apply scientific knowledge. The definition is that it's a methodology by which actionable insights can be inferred from data. So this is the very objective of this science. And what is important about this is that we are going to contribute and make in order to design experiments, many different actors that come from computing, from the context in which our experiments are associated. For example, if you want to run experiments on data regarding cinema, and we want to understand cinema in an artistic manner, well, there we have to make cooperate computer scientists, cinema experts, and maybe images experts in order to run our experiments. And if we are addressing industry, well, we need industrial engineers so that they can participate in the design of the experiment in order to answer their questions. Okay, so normally this design calls for the expertise of many different disciplines. And the objective is to produce beliefs informed by data and that can be used for decision making. These are examples of things that you can do with data science strategies. You can prove reality, you can discover patterns, you can predict events, you can try to understand people in the world. So many different applications that can be addressed with data science. Now, in order to start digging into the experiments, we can classify the type of experiments that we can design and run according to their objective. So in the first line, we have many different tools that can be used in order to achieve three main objectives. We can have the objective to have insights of phenomena. Remember that we are going to suppose that the data that we have are observations of phenomena, retail phenomena, industrial phenomena, economic phenomena, whatever, okay? So these observations we would like maybe to have, first of all, insight on them. This is in order to know what happened, okay? This type of questions. Then we might have also the objective of have insight about the observations, which is why did it happen, okay? And eventually we might have the objective of predicting, having foresight on the phenomena. So what will happen if, and the best of the best, when I really master the phenomenon, is how can we make it happen, okay? How do I reproduce this phenomenon? And depending these types of questions that we might want to answer with experiments, then we have different tools, okay? That are represented by four main umbrella. So in order to answer what happened, you might need to apply this descriptive analytics. If you are willing to do descriptive analytics, there are many mathematical tools that we all, we have studied engineering in its different disciplines, we all are able to apply these kind of tools in order to have insight of phenomena. So statistics, essentially probability and statistics are very important tools when we are willing to run this kind of experiments. What am I doing here if I do not do statistics and I'm not an industrial engineer? Well, since we have volume, since we have computers, the idea is to put computing solutions in the table in order that people can design their experiments using this with data, with volume, and applying these tools that we all are acquainted with, okay? When we want to know why did it happen, then we are addressing diagnostic analytics. And there are other tools that come from different disciplines, for example, from computing, from machine learning, artificial intelligence, and also from mathematics in order to have this diagnostic analytics. Then when I want to predict here, well, this is by construction, okay? This doesn't mean that I'm using machine learning but not the others. I'm using all plus machine learning, okay? So in order to predict, well, you all know, for example, regression. The families of regression can be two mathematical tools in order to do prediction, okay? So there you have these mathematical tools, but in many cases, these tools require data to have specific formats and to have specific characteristics. And when this is not possible for some reason, so there are other alternatives that come from a discipline called machine learning and artificial intelligence discipline that have provided algorithms in order to address in an alternative manner, for example, predictive analytics, okay? And then if you want to reproduce and understand how you can make happen phenomena that you have observed, then there are other artificial intelligence tools that can be used in order to do this kind of experiments. And again, that use, many of them use statistics, use probabilities, they use also linear algebra techniques in order to run their the background of their algorithms. Okay, so a lot of mathematics, a lot of statistics, plus algorithms, which are mathematics also, in order to address these different kinds of experiments. And again, what is the question? Well, the question is when to apply which algorithm and which model according to the type of experiment that we have to design. So this is always the issue. Okay. Now, if we have a look on what, this is important because we have been, sorry, addressing some of the aspects here. So if you want to classify which techniques and where do different strategies are positioned with respect to data, since data are the backbone of all these experiments, you can reason in the following manner. You can reason on the degree of rawness where that you of the data that you are going to use. Okay, so in the on the left side we have raw data. Okay, the data that come from sensors, for example, sensors installed in machines in a flow, for example. This kind of data come in a very raw status, okay? And on the opposite side, you can have very curated data, so very well structured, smooth, with no missing values, with no outliers, or really clean, super clean data. And you can find them here in the other part of the spectrum. So for the time being, what we have been using is this kind of data in order to study the different strategies that we apply in order to query the data. So at first, in the first part of the lecture, Christophe discussed a lot with respect to relational data. Okay, so the relational model is a structured model that ensures specific mathematical properties about data, and that implies that these data are in a very curated manner. So when we have this kind of solutions, what we can do is either query in a relational manner or aggregate the data as the kind of queries that you have been doing, for example, in the first data lab on Mongo, okay? Or you can even use information retrieval as the one you are used to do using Google or a search engine, okay? So this is the zone of this kind of data. But the thing is that when we have observations, in fact, we are in the left part of the spectrum. Very often we start with really raw data, and some of them are more or less curated or not, okay? And they also, well, they can be a mess, or they can be rows of records, or they can be, for example, stored in Excels or in other type of data structures, but anyway, they are much more messy. And when you have these, here you have the three objectives that I explained regarding the experiments, but before this, you have this data exploration task. When you have data in a very raw status, you barely know what it contains. Or, well, of course, you know the context, where does it come from, but you have very few insight on what is the content of this data. So you have to apply data exploration techniques in order to figure out, for example, whether the data have some structure, whether the structure is consistent, whether there are some missing values, okay? You can have observations when some of the values, even if the structure is consistent, are sometimes missing, or they seem to be in a specific range, and suddenly there are some data that are out of this range. So you want to observe this. So all this, the content of the data, whether you can guess out of the values that you have, whether you can understand what the data refer to. So these kind of tasks are done in the data exploration purpose, okay? And this is a very important task to be done very often when you want to do experiments regarding insight, insight, and foresight. Okay? So there is an important exploration task that you want to do. And so for today, for this morning, we are going to range more or less here in these two, and then afterwards during this lecture with our other colleagues, you will address these parts, okay? But today we are going to have a look on how do we do data exploration and with which tools we can do this. Now, it is important since data science is a science, so it has a methodology. And the methodology can be summarized in a workflow that has the following stages, so activities. First of all, and another important thing to say is that every activity, every stage of the workflow is a problem in itself, okay? So we are going to see some of the stages in a simplified manner, but if you go to the real world, this is each one has requires expertise and requires design. First of all, we have data collection, okay? Here you can guess different problems regarding data collection. For example, which are the sensors that you are going to use, for example, in a production line in order to observe the production process. Okay, how are you going to distribute them? If you have specific environmental conditions, do they resist to these conditions? Do they start producing erroneous data if some of the conditions are not respected, etc. Okay, how often are you going to send all these observations somewhere where you can archive them? So these kind of questions have to be addressed in this data collection stage. Once you have them, then you need to explore them. Okay, so many observations: are they right, are they wrong, are they whatever? So in many in the next data exploration task, there is a lot of visual exploration in order to understand and explore the content of the collected data. Okay, so why? Because normally, before you start understanding the semantics of the data, what happens is that you approach the data in a quantitative manner. So you have a quantitative understanding of the data. And when we say quantitative, we say descriptive statistics. And when we say descriptive statistics, we have interesting plots that let us understand the content, okay? So bars and pies and all these different plotting strategies that help us understand the quantitative observation of the data. Then normally when you have raw data, and in order to use particularly many of the mathematical tools that can be applied in order to analyze the data, you need to clean them, first of all, and eventually you need to transform the data. For example, you might need to, if you have a floating point data, you might need to discretize the data, okay, for using some specific tools. Or you might need, for example, if you have strings or names, you might need to transform them into a numerical representation in order to apply, for example, statistics. So these kind of transformations are required to be applied. Then you will feed a model that will provide you with more understanding of the data. You might need to, when applying the model, you might need to continue plotting and in order to explore the results and the conditions in which data are fed into a model in order to be processed. Then an important stage is once you have a model, you need to validate the model. And again, you might need again to apply a visual exploration in order to validate your model. And once you have validated your model and that you have repeated this many times, then you can eventually communicate with experts that are going to consume the results you are producing. They might start understanding what you are proposing as result, and when you consider that the model is representative and that it has been validated, then you might deploy it in a real solution that can be used for example, for making decisions. Okay, so this is the general workflow that is applied to in data science, and it will be specialized in specific workflows depending on the type of experiment that you want to run. Okay, so this is the kind of thing that you do for designing the experiments in data science. Now, of course, I am here because these experiments, again, are run on machines, on computing architectures. And so there is a variety of tools available today in order to design and to run these experiments. Okay, so the objective of this morning is to show you some of the most popular tools today that are used in order to design these experiments. And then afterwards, with my other colleagues, there you will have to really design concrete experiments in order to address some problems. Today is more tool-like with examples in order to start having a step on this. So the use and the design of this experiment is possible because first of all, today, there is a democratized access to data collections. Okay, there exist many data labs, many collections available online that we can use in order to run experiments. So this is first important element in order to be here today and thinking about experiments. The second thing is that algorithms are also there in the form of libraries in many different programming languages so that we can apply them. So there is no need to, unless you really want to do something very specific, but in general, algorithms are there. You don't have to program them. They are they're ready to be used in order to run your experiments, okay? And they are released in many different conditions and qualities. So in order to, as I said before, but this plot is important. So the knowledge that you have today is here. So you have, because you are engineers, very good knowledge on mathematics and statistics. You have knowledge on computing, so more, I mean, maybe you haven't been developing advanced solutions in computing, but you can use a computer in order to address your problems. So this is another element that we are going to use. And what we will introduce as tools in order to deploy data science experiments is solutions that go beyond mathematics and statistics and that touch what we call today machine learning, which is a discipline within artificial intelligence. And then, of course, in this lecture, we will not address this. We will not address software development, which is once you have solved a specific problem in an experimental manner in lab, maybe in-house, then you can start deploying real solutions, and then you have to develop software in order to deliver your solutions. And of course, if you really develop them to the very end of the pipeline, then you will need to have business strategies and domain knowledge in order to sell your solutions and put them on the market, okay? Now, an important issue here that you have to consider is regarding algorithms, is that it is a forest of models, algorithms, and the first very challenging thing to do is how to choose your algorithms, okay? So it is important to know that these algorithms applied in order to analyze and to solve this kind of data science problems are organized into families, okay? So here are the most popular families that are applied in order to address analytics problems. Again, the type of questions that I illustrated that cannot be answered with classic querying. So there is, the family of regression is a very important family, but that there you have already knowledge. There are other families that address regularization, because normally in order to do for example regression, you need to regularize, and there you have these regularization algorithms, particularly here, and particularly when you apply deep learning solutions, you need to regularize, okay? Because you do a lot of test and learn, and you adjust parameters, and there you have to regularize. Then that's also a very common problem in engineering. You have, once you have an observation, normally you can, or very often you can reduce the number of variables that are representative for a phenomenon, and you can have different techniques in order to reduce dimensions. You have a lot of clustering because some of the problems that you are addressing require a classification. You have decision trees, you have rules. So these families that contain, in fact, all the most common algorithms that people use in order to address and to use these families, okay? So the first challenge in order to design an experiment would be to choose the right families that can be used in order to address your problem, and within the families, the algorithms that you would apply in order to really concretely design an experiment, okay? And there is no vademecum, okay? There is the expertise of a data scientist that cooperates and that understands the problem with the experts of the discipline that need the results in order to calibrate and choose which would be the right algorithm. Now, if we go back to the approaches, this is very important that for you to understand. So this was the first part, more or less the first part of the lecture. So querying in databases or information retrieval. And we are today moving here, and I think that in the rest of the course, we are going to move here to data science-like queries, where you explore, where you analyze in order to model and predict. An important thing to consider is that experiments, you have seen that the methodology is a workflow. So a workflow, even if you parallelize some stages, it's step by step. Okay, so these kind of queries, when they are answered through an experiment, in fact, you go step by step through the different stages of your experiment in order to obtain results, on top of which you apply other methods, and so you assess, and then you continue with this. It is also step by step and is try and learn, okay? At some points you might have decided that you apply something, you get first results and you see that this doesn't work very well, so you roll back and choose another thing. So it's a lot of also step by step and test and learn in order to completely design an experiment and then go further in other stages of its validation. Again, another important thing is that results are not definite, they are approximations, okay? So in order to assess this approximation, you need also to put together the evaluation of the degree of error that your results can have, and also other assessment scores that will say how close you are to reality, okay, with respect to either by having previous cases or by interacting with experts, okay? But it's approximation, and you have to measure your degree of error and the performance of your solutions. This is very important. And then normally what you have in with regards to data is that you have raw data in extension, okay? So with very few structural description of the data, okay? What matters is content much more than structure, even if of course structure is important. That I have said. This is just that you don't forget when you come back on the slides to what I have said. What time is it? It's just, I'm going to stop in a while so that you can breathe, and then we go back to practice, okay? So here is a general execution plan of the type of experiment, which could be a query, a pipeline that would implement the experiment, okay? So specific elements to consider. Data are observations of phenomena that are often described as features or attributes. Okay. The queries have an analytics objective. So, okay, they are looking for insights or foresights, and they are expressed as pipelines. So you see here, I will go in a minute through the details, but the query is a pipeline of operations that are guided by the conditions and the characteristics of the data. Okay, so very closely related to the content, the structure, but particularly the content of the data. And then the results are models or predictions with associated assessment indexes, not definitive, and accepted by an associated error margin, and particularly by comparison. Okay? When you want to answer a research question, or you want to validate or contradict a hypothesis, in fact, you are going to use different strategies, you will obtain different results, and you will use the result that best performs, that has the less margin of error, and that has the best assessment scores in order to answer your question or to validate your hypothesis. Okay, so you have, for one question, you have different pipelines, okay, combining different algorithms in order to look for your answer. And the pipeline looks as follows. As I said in the general description of the data science workflow, well, you start with raw data, and then a very important step in order to begin is to explore and to prepare the data. So you are going to do first a quantitative profiling, normally, as I said, done by applying descriptive statistics. Then you will combine these results by visualizing using uni, bi, or multivariable observations, plots. You can even have interactive plots in order to really explore and understand this quantitative profiling. And once you understand the status and the quality of the data that you have, the characteristics, then you can decide, for example, to do attribute featuring, to normalize, to clean, to exclude outliers, to complete missing values, this kind of operations that are called in the jargon of data science attributes engineering. And again, in order to do that, you might also use visualization techniques in order to guide you in this task. And then at some point, you will decide, in order to continue your experiment, whether you are going to use the whole data that you have, or if you are rather going to use a sample of the data. And if you are using a sample of the data, you have to decide how to build your sample. Okay. So again, you are going to apply specific techniques to be sure that the sample is useful in order to continue experimenting with the data, in the case that you decide to use just a sample. Which would be the criteria that would guide you in order to use a sample or not, besides the type of model that you are going to use to continue the experiment? Well, imagine that you decide to have a quick in-house, small size prototype of your experiment, and that you want to run it on your machine, and your machine is not very powerful. Well, then you will have to decide, of course, with respect to the mathematical characteristics of the data, but also with respect to the capacity of your computing device, in order to choose, for example, the size of the sample. Okay, so this is also comes into account when you make this decision. And once you have decided and that you have your data collection in order ready to go further in experimentation. So as I said, it depends on what you want to do. Do you want to have insight? Do you want to classify? Do you want to have foresight? This depends on your research query, your research question. So you are going to go through different steps. For example, there are models, for example, in regression that you are acquainted with. In fact, what happens is that you divide the data into at least two data subsets, now the training and the validation set, okay? So if this is required, then you have to fragment your samples, okay? And if you are in a real setting, this fragmentation has to be aligned with the fragmentation as the one we have seen today, okay? So you see there is where you can see how the data management and the decision making of the experiment itself can start interacting between each other. Then you apply whatever you decided. And as I said, there are in every step, here you can have one or several steps, and there you have to assess by analyzing errors and by using ablative analysis. And at some point you validate, and this is circular until you are happy and until you have applied different methods that you can compare, which is the one that with which you obtain the best results in terms of errors and performance scores. Okay, so this is the general thing, but as I said, in every step there are some interesting problems to be addressed. So today we are going to stay here. Okay, we are not going here. This is for my colleagues, but today we are going to stay in this first part of the pipeline. So let's have a look at an example of experiment that you might want to run with respect to a question. Consider, for example, a scenario where we have urban data. And the question that, well, this urban data have consist of many different data. They can concern, for example, in-house variables observed. You can have meteorological data, so this kind of data. You can also have data on the city that you're living in. And for example, the question is, does it make sense to invest in low carbon technologies at home? Okay. So the idea would be to use this data in order to design an experiment. And the experiment, well, I have another example. This is regarding the house. You can also, for example, consider that you are in town and what you want to answer is, will jogging in the morning around the river next weekend reduce breathing CO2? Okay. So as I said, in order to build an experiment, we are going to design a pipeline. And a pipeline, just to give you the definition, is a complex and repetitive processing and analytic set of tasks. Okay. So in order, for example, to answer my question number 2, I can have 2 different types of tasks. The one that concerns querying, retrieving, and aggregating data. For example, preparing my data, let's say that we collected data on the quality of the air around the river in Grenoble during several months, okay? So I need to prepare my data. I need to estimate, out of this, I need to estimate traffic, and this is an aggregation operation. And then I can go further and start exploring modeling and predicting. For example, I would need to model traffic and the CO2 production. Okay, this would be one of the elements of my experiment in order to answer my question. And then once I have modeled this traffic and CO2 production, then I can predict whether, well, the amount of traffic and CO2 emissions around the river next weekend. And with respect to this, and according to some results, I would, at the end, let the person decide whether to jog or not next week. Again, for the low carbon technologies, well, this would look more or less the same. I would have to prepare my data, model energy consumption, estimate CO2 footprints, and then predict energy consumption and CO2 footprint in order to decide whether it is reasonable or not to invest in low carbon technologies. And if we zoom, just to give you a look on how we would go further from this pipeline, well, in the data preparation tasks, I would, for example, according to the data, I would have observed in-house and methodological data. I would have to see whether my data contains outliers or not, what is the distribution of the data, have a statistical analysis the data, and this all would give me an understanding on the data that I have in order to try to answer my question. Then at another step, I would have to determine CO2, use CO2 cost formula in order to estimate CO2, and then apply different time series analysis methods in order to determine, to predict my consumption. At some point, I would conclude, for example, that if I invest on this type of technology, I would reduce CO2 in Christmas and summer, for example. Okay. Now, how do I do this? Okay, imagine that we are experts, that the pipeline has been designed, but now in order to really run all its stages, I need toolboxes to do that. Okay. And so the solutions come in many different manners. First of all, as I said at the beginning of this session, I'm trying to present tools that go really in scale. Okay, this doesn't mean that if you are running your experiments in-house, you cannot use your own computer and have a first approach on the experiment. Okay, but I'm addressing the situation in which you really need important resources. Okay, so just in general, in order to access these resources, as we said in the theory part, there are many different architectures, but a very popular solution that is extensively used today is our cloud architectures, okay? Because they provide different types of services in a very transparent manner. And since we already have the problem of defining and designing the experiment, which is a very complex problem, we do not want to struggle with technology in order to do our testing and running our experiments, okay? So this transparency is also interesting because of this. Okay, just to be sure that we are on the same page when we talk about cloud, the cloud is an architecture, and it provides ready-to-use environments in order to store big data with the properties that we introduced at the beginning of the course. and running greedy processing tasks, okay, which correspond to the tasks that compose our experiments. The cloud promises unlimited access on resources, okay, in an elastic manner. And this is another key element that moved a lot of people in using these type of solutions. The unit of understanding of the cloud is, and the delivery of resources is a service, okay? And services are organized in a reference architecture into 3 levels. You can have infrastructure services, which are CPU, RAM, and disk. You can have platform services, which are frameworks, developing frameworks, for example, database systems in the platform as a service family. And then you can have other software high-level solutions services, which are the software as a service family, where you have full functional software. Examples of infrastructure, for example, if you use a Dropbox, you are using a disk, and you are also, if you have the application of Dropbox installed in your machine, you are also using software as a service, which is a file system that lets you explore the data that are stored in several storage supports, okay, for example. Now, and this can be configured according to your requirements. And regarding data science, many vendors provide you with built-in solutions in order to do data science. And these solutions are provided as virtual machines or as Docker. Do you remember from the last hands-on tool? Well, you can have virtual machines that integrate many different tools that are intended to be used when we run experiments. This is the example of the Microsoft solution, but there are other vendors that provide these virtual machines with languages, with algorithms, with visualization tools, with execution platforms for ingesting, for example, data when there is a lot of velocity, and other development tools that can help us implement our experiments. For example, here you have R, you have Studios, you have Python here as query languages, you have R query language, things like that. Okay, so all necessary, intended necessary tools that you would use in order to implement your experiment. But in fact, the spectrum of solutions is much more complex than this. And the type of solution that you use depends on the moment in which you are with regards to the implementation of your experiment, okay? Of course, at deployment time, well, you need a real infrastructure with a lot of resources so that your experiment can run and can be used intensively by many users or by an industry or whatever. But this doesn't happen all the time. You might be in a point where you just want to understand the problem and figure out a solution, and then you do not need the whole cloud in order to address your problem. Okay, so this virtual machine, as I described, with other types of solutions that are normally provided by clouds, can be grouped into the family of big data platforms as stacks. So you have stacks of solutions at the back end and the front end, and they are delivered to you in order to design experiments. But you have other intermediate solutions that let you start approaching your experiments. And these are IDEs that some of them run on the web, or you can install them locally in your machines. And they can also run on top of clouds. So you still have important execution resources, computing resources, but in a very familiar and very simple implementation environments. Today, what we're going to do is we're going to work at this level, okay? And then there are other solutions, huge solutions that provide important large-scale resources that are called machine learning services and studios, and these are intended to really deploy the solutions in an industrial context with maintenance and with different life cycle stages that we will not address in this lecture. Okay, so we will stay here. Okay. Well, this is animated because it's cute to animate, but well, okay. Now, an important thing to consider is that in all solutions today, there is a divide between what regards data with respect to what regards, here it's called an artificial intelligence, in fact it's a model applying, okay, analytics, okay? So these two families of tools are today separated. And it is up to us to join them in our experiments, okay? So you will need data loading, you will need making data reside in memory or in cache. You might need indexing as the type of indexes that you applied in the first data lab. You might need to make data persist, to optimize, etc. But these type of services are provided by solutions. For example, here you have MongoDB, but you have to create the bridge between this and your data science experiments. Okay. Today, well, in particular in the project, we will give you an example on how to do this, even if, of course, this is much more complex than it seems. But these problems emerge particularly when you are at the deployment stage. When you are running your experiments in-house with the type of solutions that we will see today, I think that you have enough and you can do very interesting things without having to tackle this divide. But it's important that you know that when you really go to deployment, industrially speaking, that people have to address with this. Now, some comments before we stop a little bit to grab a coffee and then we start with hands-on, is that today data science pipelines are designed in an artisanal manner, okay? This is why data scientists are today very, very required, okay, in industry, because this is what makes a solution run and be interesting, and this depends on the experience of data scientists and data engineers. Another important thing to consider is that the experiments and the pipelines are done in-house, okay, with libraries, with stacks and tools that are difficult to integrate, okay? So you really have to be sure that which are the libraries you are using and making them available in your execution context so that they can run properly, your experiment can run properly, okay? So there is no nicely integrated solution, even when you have these data science stacks. So it's up to the one that implements the experiment to integrate all this. Even if you will see that we have, I mean, there are huge advances here in today's tools. Then other challenges that are not addressed when you do a first step of experiment, but when you deploy, these are to consider. So, So you need to consider efficiency, execution. So this is a very important engineering effort to be done. And then tuning for improving data management across the nodes. So for example, a cluster or things like that. This is also something that has to be done in an intelligent manner, and this has to be tuned. And this is still not transparent to data managers, okay? So not to final users. I'm going to skip this because we will see that later. So before we go for a break, the first thing anyway, beyond the tools that you need to use in order to implement your experiment is a data programming language, okay? So there are many popular programming languages that have been used for a while in experiments that today, as I said, are considered within the umbrella of data science, but that have been there in engineering solutions for a while. For example, I suppose that in industrial engineering, sometimes you use MATLAB, and today R are very popular solutions for developing models and addressing problems, okay? And yet today, from the computing science arena, and because it has very interesting programming properties, emerged Python, okay? It's a programming language that is very popular today in order to implement experiments. So we, in this, in the data lab that we are going to do today, we are going to use Python. Don't be scared, you will see it's a very simple programming language. And later on in the course, you will use R. And this is interesting because you will be able to compare both solutions, and you will see that they are more or less equivalent. It depends on the kind of flavor that you want to have to address your problems. So with respect to Python, I have said that statistics is very important, that linear algebra are very important tools in order to address experiments. So Python provides libraries that have all necessary data structures and operations in order to address matrices and apply linear algebra operations on them, okay? And this library is NumPy, that contains all you need, in fact, in order to play with matrices and apply linear algebra functions. Then in many engineering problems, people apply numerical algorithms. So the SciPy library contains almost anything you need in order to apply numerical algorithms. It also provides signal processing, optimization, statistics. So all the mathematical tools used in engineering in order to address problems. Then, since we said that visualization is a very important element in the workflow, there are libraries. Matplotlib is the most common one, but there are other funky ones that let you plot your results and your data. Then in many experiments, as I said, people apply machine learning algorithms, and they also apply, well, here regression is included in machine learning, even if it doesn't belong to machine learning. But anyway, so you have all necessary libraries in order to apply models, to classify and to predict. And this is the scikit-learn library. And finally, many data come, since we have said that observations are sets of attributes. In fact, there are records. So a very common and popular way of representing these observations are tables. Also because in some contexts, Excel, for example, has been used in order to store the data. And what is Excel? Well, it's a table. So Python has a library called pandas that lets you operate on tables, okay? And you will see that table, if you have done some programming, is very useful because with tables you represent graphs, with tables you use mathematical representation to address relational data. You can also use tables in order to represent documents. So table is a very important data structure. So pandas is a key element in Python. Now, how are we going to use Python? Well, we are going to use Python in what we call an integrated developing environment. So this means that all the libraries and everything necessary in order to program in Python, you will have it in this IDE, Integrated Development Environment, okay? Now, in these environments, you have, of course, a compiler, and well, Python is an interpreter, so you have all the things you need in order to do that. So these IDEs, you can run them locally in your machines. But as we have seen, we have machines of many different characteristics, properties. You have installed your own software and you manage it the way you want. So installing and coming with new software, it's not a very practical way when you have to do a data lab of 1 hour. So, and this happens to many people. So people have started to put these IDEs on the web. So in a similar manner that we used Play with Docker, but this time this is not a sandbox, so you can keep your operations that you did. You can use these web IDEs in order to access Python libraries. And when you use these IDEs, what you will use in order to implement your experiment is what we call a notebook. So experiments in these kind of environments are expressed as notebooks. And a notebook consists of cells. And you have two different cells. Code, a cell that contains code. For example, if you're working in Python, it's Python code. And other types of cells that are used to write text in a very popular format today, which is called Markdown, okay? So Markdown is a text format used on the web and on notebooks, etc. And so the idea is that as if you were a biologist or chemists, you run your experiment, in fact, is a log of all the steps that you run in order to get to a result. So you have the commands and you annotate the purpose of the commands on Markdown, and you start interpreting the results that you start obtaining and the decisions you make in order to go further in your experiment. So at the end, you end up with a description of the solution that includes the code and the data needed to reproduce your experiment. And this is key because when we are in experimental sciences, we need to reproduce our experiments from our own, and we share them to others in order that they can run and they can evaluate and see how our experiments are interesting, valid, etc., or not. Okay, so these notebooks are very interesting because of this. So you need environments to run these experiments. Jupyter is a very popular one that is able to run notebooks written in Python. So a notebook looks like this. So you have here, for example, you have this markdown that says the formula that was applied to data that were imported here, and that are the results are plotted here. So this is how it looks like. We are going, this is the overview of the type of tool. So now we are going to have a break of 10 minutes. So we will be back at 10:10, and we will start playing with an environment and for starting define our notebooks and doing some data preparation tasks. Okay, so 10:10 we are back, and I let you breathe and grab coffee, me too, and I see you later for the hands-on. Remember just that I need you to create a Kaggle account. I gave the details on my email, so be sure that you have your Kaggle account created. So see you in 10 minutes. I'm going to pause the Okay, so behind the scene with what we're going to do in the data lab. As in the previous one, we have prepared code and particularly data on GitHub, okay? So remember that GitHub is a service that provides you with resources in order to manage code. Particularly what you can do is versioning your code. It provides you with a file system where you organize the code and the libraries and data or whatever you associate to your code. And of course, if you have a file system, in fact, it provides you with storage support in order to deal with all this. So this resides somewhere on the net, and what we see is the service accessible either by an API or either on the browser to access what we need. Okay, so for these new data labs, what we have done is prepare all the data collections necessary that you will need in order to run your experiments. Okay, so this resides here. Then Kaggle. Kaggle is a cloud service from Google that provides two main type of services. We will go through Kaggle in a moment, but what it provides is a data lab that lets us deal with raw data collections in many different formats. And what we do is we can either store them privately, or we can share them with the world. And these libraries, what Kaggle does is it associates metadata that can let people understand what the data they are sharing are about. So you can describe, you can also use tags, and Kaggle generates quantitative observations of the data that you provide. Okay, and you can also have versions of the data. So there you will see in a minute, you find data about anything you want, okay, public data. For what? For being used in the second type of service that it provides. In fact, it provides a running environment of notebooks that can be written either in Python or in R. These notebooks in these running environments are supported by computing infrastructure. Okay, so the computing infrastructure is provided by the Google Cloud, and you can either, well, you can choose them. They provide you with several nodes in order to run your experiments, and with two types of hardware, either CPUs, so the ones that we are used to use in our machines, but they also provide with GPUs, which are high-scale execution chips. Normally, they used to be used in for videos in order to have good rendering in videos, but today they are used for running machine learning algorithms. Or you can use also tensor processing units, which are processing units well adapted when you use a lot of matrices. Okay, so they provide you with these, also with storage support, and of course with a file system where you can explore your data. So Kaggle is here. It is a service of the Google Cloud, and it gives you access to all these different things. So of course, we are using the free trial. The free trial provides you with a lot of things. If you have a Google subscription, then you have further things to use. But we are using the free trial. And all these two elements that we will use in the data lab are, of course, accessible through a browser. Okay, so what do we need in order to run our experiment today? Any device where you can read and tape that has connection and that has a browser. That's the only thing that you need. Just give me 1 second. Sorry. Okay, so we need a browser, and through the browser, we are going to access to all this environment and also to GitHub, okay? So this is behind the scenes. So let's go for the real scenes. So you are going to, with me, we can, I don't know why my Facebook keeps appearing. Anyway. So I'm going to go to my Kaggle. And if it connects one day. So what do we need? We need, as I said, Kaggle. I'm going to open a new one because this one is for later on. Okay. So if you go to kaggle.com, where you will land is in a kind of a page like this. Here you have your profile, and then in the left side, it provides you with different tools. First of all, it provides you with access to the data lab. Okay, so the data lab, I have a nice picture of the data lab. Yes. So the data lab, there are many different vendors for data labs, okay? So you can either use Kaggle, there's also another solution from Google called Colab, there's another one from Microsoft called Azure Notebook, so there are many different data lab vendors. So any data lab, what we'll have is storage support, access to storage support, either on the cloud or in local disks where you store your data. Then tools in order to go through your data, file systems, and other types of tools that give you comfortable access to your data, and then different libraries that let you play with your data, okay? So in the case of Kaggle, what you have is, if you go to data, you can access and create data sets that can be public. You can have your own data sets, and you can also tag them and have favorite data sets. Okay, so they are tagged by topic, by type. And let's go to this one, for example, of the US election. So if you go to a data set, what you have is a site where you can give a title to your data. You have the author of the data. And then you have an explorer. For example, this data consists of these different files that are represented in a CSV format. CSV is a tabular representation format of the data, okay? So this data collection consists of all these files. It has in total 12 files, and for each file, it provides you with a description. For example, it gives you the attributes. So since it's tabular, you have columns, so it gives you the different details of the columns of each file. See, for example, here. And it also provides you with statistics, okay? So the in state, Vermont appears concerns 44% of the collection. New Hampshire, 19% of the collection, okay? You can have a detailed description, you see, with graphics of the distributions. Then you can have a compact overview where you have the state and the values, and you have also a description of every column with its statistics. Okay, here, for example, the column county has 864 unique values. All are validated, some are mismatched, some are none are missing, and unique this amount, and so on and so forth for every column of every document composing the data collection. It also gives you description of, if you want to associate tasks to the collection, you can add it. If people have run experiments on this data, it connects you with the experiments that have used this data collection. It works as a social network, so people that have used the data can discuss on different aspects, either of the data or of the experiments that have been run on top of it. It also gives statistics of the activity, so you see the data collection started to be popular the 5th November, and then it became very popular the 11th November with this amount of views, this amount of downloads, contributors, download per view ratio, etc. And it also has associated metadata, which are important when you are running experiments. For example, you need to know the type of license associated to your data collections, because I mean, here in my speech, I have been talking about collections that they are democratized, but in fact, not all data collections can be used for any purpose, okay? So normally they are associated to a license, and so it is important that when we use a data collection, we are aware of the type of license that is associated to it. For example, this one is public and is public domain, but there can be different licenses. So if you are sharing yourself some data collection, you can define the type of license that you associate to it, or you can decide whether it's public or private. Then it also says the provenance of the data. You can imagine that if you are running an experiment in order to make decisions, in order to have an understanding of some phenomenon, it is important to know where the data come from, because this provenance adds or not validity to the experiments and the results you are going to produce. So for instance, here the data has been produced by Thomson Reuters and loaded through a web service into Kaggle. It says also who maintains the data, and I'm not going to click here, but users of Kaggle have reputation as the one we have for in social networks, so you can see whether the person is how much reputation it has with respect to the community, she has with respect to the community, and so to determine also the kind of validity that this data can have. It also describes how many times and how frequently the data has been versioned. You see here we are dealing with the 64th version of the data, so it's quite updated. It has been quite updated. And then the coverage, it's a spatial coverage, and then it regards only 2020. Okay, so this is the whole vision of the data collections provided by this data lab of Kaggle, okay? And then here you can see that you can download your data, the data collection, or you can use it in notebooks in order to run your experiments. Okay. The second service that Kaggle provides are notebooks. So as I said, notebooks implement different experiments. And again, here you have experiments from many different types. You can see whether they are written in Python or in R. They have comments, and again, the community can interact a lot with each other in order to develop these notebooks. They can be public. This concerns, for example, this is my work. These are the notebooks that I have been running. People can share the notebooks with you. For example, I teach in another school, and so these are the notebooks that have been produced by the students and shared with me so that I can grade them. And I can also have favorites if yes, I do have one favorite. See? Okay, so, and I myself can create new notebooks. Just to give you a general panorama of it, Kaggle proposes competitions very frequently on many different aspects, and people can inscribe, and there is a monetary prize behind, and you compete with people all over the world. They give you some weeks in order to address a problem. They give you the data, they give you the tasks. You can inscribe, and if you win, you get some prizes. So in engineering schools and yes, more in the engineering schools, even if independent people also participate, it is very popular that students get together and address some competitions. And then the results and all the notebooks produced within these competitions are shared also, so that people can see the type of problems that have been proposed and the way people address these different problems and who got the best results regarding these challenges. And of course, there are courses too, if you are interested in digging more on data science aspects, okay? So today what we're going to do is the following. We're going to use Kaggle, the notebook version of Kaggle, and in order to get acquainted to two exercises. The first one is how to deal with tables using pandas, and the second one is how to use descriptive statistics to explore the content of a data collection. Okay. Now, in order for you to have the instructions of the exercise, you have to go. I'm going to close all this so that you can. I can better show you. So if you go to the Google Classroom, it's important that you go because there we have all the details. Okay, so it's hands-on 3. So we have, all of us have created a Kaggle account. We have followed the instructions in order to create it, so that's fine. And well, the idea, so you have to make sure that by the end of this morning, you can explore your data collection, you can observe the metadata, see curation information, create your own data collection, and then explore it, okay? So first part of the exercise, we are going to prepare our environment, and in fact what we are going to do first is get all the data that we will need from GitHub and put it on the data lab, okay? So therefore, we have to follow the instructions that are given in this first link. You will see that it's very easy. I'm going to show the link, but I'm going to do with you step by step so that you can configure your environment. But if you get lost at some moment, or if you decide to do the same procedure at home, you have all the details here that can guide you if at some point you are lost. Okay, so we have created the account and we are in the Kaggle. This is an old version of the site. They change it a lot, but it looks more or less the same. Okay, so I'm going to close this. The first thing that we are going to do is create a new data set, as I said, from the data that resides now in GitHub. So you have to go to the data lab and click on new data set. And you will have this formula. So I let you give you a minute to land to the same formulary. So we're going to create a new data set. We have to give it a name. I'm going to say AG data. But you can name it the way you want. So there are two possibilities. If you had your data locally, you could drag and drop it here, or you could select it from your local disk, but we are not going to do this. We are going to load data from GitHub. And remember, GitHub is this cat octopus here, this little cat. So we have to choose this option. Tick. And we have to provide it with the URL in GitHub where we have our data. So this is given here. Okay. Do not hesitate to Slack me or to open the mic. We need help. So this URL is given here. And well, it connects to this GitHub, and it gives you a preview of all the things contained in this URL. As I said, it contains different data collections that we will use in today's exercises. I have a Slack. The URL for is when I went to Classroom, I clicked on Hands-on 3 and I clicked here in the first link. And if you click there, you land here. Let me give you a second to. I'm going to put the link directly on Slack so that it's easier for you. Slack here. So the link is on Slack. If you click to that link, you land in this site, getting started with Kaggle. And you scroll a little bit. You scroll a little bit, and then you have the formula that we have here. Well, just a second before, and you copy this URL, the one on GitHub. You paste it, and when you paste it, you suddenly have this, okay? Which is the preview of the content of this link. And then you can click on create. I'm going to wait for a minute so that I'm sure that everyone has reached this milestone. And then if you click create, blah, 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 it lets a little bit. And when you get success, you go to your data set. And of course, you can change the wall, the representation of your data. And it's a social network as we are used to deal with. And now that you have your data collection, you have it provides you, Kaggle provides you with some hints so that you can manage your collection properly, and that eventually you can tag it and put metadata and maintain it. Okay, you see you can add tags. It already has this explorer. So this is the file system. You can go to, for example, here, and it gives you the description of this data collection. You see, only on the numerical values, it creates a plot of the distribution. Then if you go to metadata, you can decide, for example, now the license is unknown and the data are private. But you can edit and say, associate a license, and eventually, if you want, put it public if that's your wish. For the time being, there is no notebook associated to it. Okay, so first thing that you have to be sure is that you create your data collection and that you are more or less comfortable in exploring all the details of it in this description of Kaggle in this data lab. You see, it estimates, for example, the usability of it. I have a question here. Done. Okay. Excellent. So next step is we are going to associate a notebook to this data that we have. Okay. So again, all the instructions are here. I'm here. Okay. So here you have this black button saying new notebook. So you click on it. And what it does, it connects you with the execution environment. And as I said, in these execution environments, what we compose are notebooks. In the left part of the notebook, you can name it. Okay, so let's say EXO1 panels. In the right part of your the space, you have a file system. So it says the data used in this notebook are edgy data, so the data collection that I created. It will put results on this direction, Kaggle working. It is written in Python and it has no accelerator. So we're using the classic form. We are using GPUs, and then when we will run, this goes red or not, depending on the amount of CPU that we're using, space, and RAM. So these are the cells. They look like this, and as we said, it can be of type code or markdown. As I said in the theory part, experiments are run step by step. A step is a cell. So you have to run every cell. And in order to run a cell, you can use this arrow or this arrow. Okay, so you choose your cell and you click here to run, or you choose your cell and you click here. And when you have many cells, you can also ask it to run all in a batch. Okay? So the first piece of code that you have here is a code that does the following. You see, we are going to use the NumPy library and the pandas library. Pandas to play with data frames, with tables, and NumPy for playing with linear algebra operations. And in order to guide us with all the paths associated to the data collection that we need to modify our instructions when we need to retrieve the data. It provides you with this piece of code. So if you run it, you see the result is all the paths where you have data. So I have in this path, I have this data in this path, there are images, many things. Okay, so you have this, all these paths. This is useful because we have to modify some of the instructions of the exercise with the right path. Okay. And then an important button is this share button. In order to send me the results of the final results of your experiments, you are going to click here and you are going to add me, well, put it public, and then you can add me as, or even private, but you can add me as collaborator. So you will look for my name, where am I? And you can add me. And with that, I will have access to your notebooks. Okay, so no need to download and store. No, you share that with me and I can have a look. And again, if you have problems, for example, you can also share the notebook with me and I can have a look and help you. Okay, so we're ready to start the exercise. Again, you go to Google Classroom and we're going to access to the real exercise, okay?
I have just a question. You have to put your profile as a writer or only a reader?
You can choose if you want me, you want to let me write, you can put me in write mode or in read.
Okay. Okay, thank you.
You're welcome. Now for the exercise, the first 4 parts are intended to help people if they use local Python in their local machines. This is not our case, as I explained, having local machines playing in distance is not a very practical thing to do. So we decided to go external and online. And so the first 3 sections, you're not concerned. But eventually, if you decide to install Python, then locally you have the instructions there. So we are starting from number 4. As you have seen, we have already imported these 2 libraries. A detail, we say import the name of the library, for example, pandas, and we can give them an alias. Because in the code, we will start referring to the different functions and data structures that they provide. And so we have to say pandas data frame, pandas dot the name of a function. So it becomes very verbose. So we define this alias so that our code is less verbose when we use the libraries. Have a question on Slack? It's the Slack bot. So we did the same with NumPy, and we are going to add a third import, which is matplotlib, because we are going to plot some things. So copy this import and you go to your notebook. And after having, you see, you have these two first imports and they have already their alias. So you come here and you import matplotlib. And just as example, I can decide, for example, to say here in Markdown, we added a supplementary library for plotting results. And you can put it bold and you can put it in, as a title or as a subtitle. This is smaller. See, you can add images, whatever you need here too. So I have this, very nice thing, and then I have my import. So all the comments that you need to guide you in the understanding of what we're doing, you should write them on Markdown cells so that you keep track of all the things that we're doing. Put my face here. Now, the first thing, before we really get data from our data collection, I'm going to show you a way of creating a table of data. And in order to give you the flavor of the language, I'm supposing that you are not acquainted with Python. If you are, well, just be patient some seconds and then we go to pandas. So in Python, a very popular data structure is a dictionary, which is a kind of record, you see? So for example, here in data, in this variable, I am creating this dictionary, which says that it's a data structure that says that I have an attribute year and I have this list, this set of years, okay? I have an attribute team, and teams can be all these teams. I have an attribute wins for the matches that this team won, the results, the draws, and the losses. Okay? So I'm creating a table of results of some matches run by these football teams across from 2010 to 2012. Okay, so this is just a data collection that I created manually. Okay, what you will see is that you will get a real data collection from the ones that we created. This is just to let you have a look on how to deal with this data collection. So this is a tiny data collection. And then what I'm going to do is I'm going to create a table format for this data collection. For that, I'm going to use pandas, and the unit this tabular data collection in pandas is called data frame. So we are going to deal with data frames. I'm saying here that I want to create a data frame from the data contained in this variable, which is this one. And I'm going to name the columns of this data frame, of this table. So I'm going to say that it contains columns. And here I am using the same names as the columns here, okay? But you can use XYZ or whatever you want. It's just the name that you are giving to the set of columns composing this dictionary, okay?
Excuse me.
Yes.
I don't find this page. Where is this page?
The page, I put it on Slack, but it also is on the Google Classroom in the assignment. We first, this is a configuration of the environment, and this is the exercise that I'm doing now. HO1.
Okay.
Okay, but I put it on Slack so that you can you shouldn't go back and forth in the sites. I have another question. And Luisa, sorry, put the the link there too in the chat. I'm going to copy here and put in. This is the one. Yes, thank you, Luisa. So those that do not find it, we have it in the chat and we have it on Slack. Okay. So, so I'm going to close this. So let's have a look at how does it work. So you add a cell code sorry, and then I have my data structure and the creation of my data frame, and I run. When you run, it gets here orange, but well, this one took very few seconds, so you barely see this. Now, nothing happens. In order to see how does this data frame looks like, note that the data frame is contained in this variable. So if you put the name of the variable, it shows you its content. Okay, so some characteristics of the data frame. The data frame has columns, which are named, and the records are associated to an index. This index is not part of the data frame. It's just the index of the records, okay? But it doesn't make part of the structure. So here you have the years, the teams, how many times they won, they drew, or they lost in the different years. So difference, this was a Python data structure, which has been converted into a table, into a data frame using this function. We will do the same procedure in the following lines. We will get CSVs from the data collection that we have created. We will transform them into data frames, and then we will play with them, okay? So let's continue with this. Now, for number 5, you can decide whether to work alone or in groups. I do not know if you even know each other or if you see each other. So if you feel comfortable and that you know people and you want to work with them, you can have groups of 4 at most, and then you work together. But if you do not know anyone, or that you want to work alone, okay? So just let me know, but that's the only thing, okay? Now, instead of this, so you do not have to send anything to my email. You will share your notebooks, okay? Using Kaggle. So in a markdown at the beginning, you say authors and you say yourself, or at most 4 authors of each notebook, and then I can. Now, for the real exercise, what we're going to use is a data collection regarding education data. So it's the education level of European countries, okay? The data come from Eurostat. They can be used for non-commercial and commercial purposes. And they are formatted in CSV. When you use CSVs, it is important to know the delimiter used to separate the elements of the data. How do you know them? Well, you can go to Kaggle and explore them, and it will tell you which is the delimiter. It can be a comma or a semicolon. Now, usually it's a comma, but it can also be a semicolon. Okay. So now, instead of having created by hand, we are going to retrieve the data contained in this CSV and create a data frame. Okay. So first, we are going to read the CSV and put it in a variable. Okay. Now, in the case of Kaggle, this is not the right path. Where do we look for the path? In the first list of things that, that we executed first. So I'm going to show you now. You see the paths, the real paths of our Kaggle notebook are given here. So instead of this, I have to complete it. If you see, we have to complete it with this first part until files, which is the one missing in my instructions. You copy and you paste it here. So normally it should say /Kaggle/input, the name of your data set, and then what we have files. Okay. So I'm saying that I'm retrieving a CSV that resides here and that has 3 columns. How do I know the name of the columns? Again, because I went to the description of my data collection, and then there in the data lab, Kaggle tells me which are the attributes of them. Oh, if you want to, I can show you. I'm gonna open a new Kaggle. So I'm in CH2, this is the organization. And you see here, I have the attributes. Let's have a compact web. You see, so I'm just reading time, geo, and value. These are the ones that I am taking. It has 5, but I'm just getting 3. Okay, and this is set here. I am using this file. The separation is double point, and I'm only using these columns, 3 of them instead of 5. So here, that's the first instruction, reading the file, associating it to the variable edu, and edu, I put it here, and it gives me the content. So I have my 3 variables, my 3 columns, and the content of each column. If you see here, it says that it has 384 rows and 3 columns. Yet here, I just have pieces of the table. So we have to explore the table in order to see what's here and that it's not shown. So this is applying, well, here you have to answer, but when you have these questions, you can add them to in Markdown and then you answer. So let's answer this first one. I'm going to copy and then I will say, I'm going to Markdown. And I say 380 rows and 3 columns. And these are a little bit dull questions, but the idea is that to draw your attention on the results. Now, let's explore the table, the data frame. It is contained in my variable edu, and I can say that I want to see the head of the table. And I just see the first elements of the table. I can ask it to show me the last elements of the table, the tail of the table, which are those you see that are here and here. You see, this is head and this is tail. Before I continue selecting the other elements, I can ask for a description of the content described, of the content of my table. And I can say this and look at what it does. Well, of course, it provides us with statistic information of the numerical columns. In this case, the numerical columns are time and value, okay? And it says how many values of time do we have and of value. The mean of the values contained in these columns, the standard deviation, the minimum, the quartiles, the maximum. Okay, so it provides you with a one-shot statistical description of the data that we have. So again, as I said in the theory part, it's to start exploring and understanding the content and the status of the data that we are collecting, we have collected and that we are going to use. Okay? And this is important because this will let us decide how to do feature engineering, how to clean, how to complete, how to delete, do not consider some rows that might be corrupted, these kind of things. Okay. Now, there are two operations that I think that you are acquainted with tables that can be applied to a table. Either observe a subset of columns, which is a projection, or selecting some subsets of rows, which is a selection, okay, in the relational jargon. So in order to project, for example, I can project only my column value. NaN is non-defined. You see, so we have missing values here. It tells me the name of the column, the length, so how many rows do I have, note that the indexes start to 0, so we have 384. And it tells me the data type. So we have a float 64. And then I can, as I said, I can select, for example, I am interested in observing rows between 10 and 13. You can also note this is not a country. So we have dummy countries in our data collection. And we can combine selection and projection. I want to select records from 90 to 93 and observe only project on the columns time and GEO. And then in order to be sure that the result of this operation is a data frame itself, I need to, it's like a cast. I need to reproduce this, transform it. So I have my columns for my records from 90 to 93, and I am only projecting time and GEO. And then I can play with many different things. I can project the column value and then select only those values bigger than 6.5. And I want to observe the tail of the result. Tail is a way of selecting. And then, for example, I can filter missing values. I have a special function which is null. So I am looking for null values in the column value. And I want to observe the head. Why is it important to observe where do I have null values? Because I have to decide how to deal with them. Either, for example, how do you deal with null values? You can either go to the values that you know, and for example, compute the average, and every time that you have a null value, you put the average. You can extrapolate or interpolate. You can delete the rows that have null values and reduce your data collection only to those rows with non-null values. Okay? So the way you impute the null values depends on your decision, depends on in fact, what you have to do is you have to interact with the one that is going to consume the results and tell the person what is the best choice to do. If you do not know, then you have to run different experiments with different alternatives and see how the model, how the models behave depending on whether you keep or not, or you impute the null values. So you see here, I have these dummy countries with these null values. Now, of course, there is a bunch of functions aggregation functions that I can apply to my data. I can count, I can do the summation, the mean, the median, etc. An important thing to consider only for when I apply aggregation functions on these data frames is that the result is not a data frame, but it's a data type in Python called series. And why do I need to know this particular situation on aggregations? Because if I want to continue reasoning and manipulating my results, I have to convert this series into tables, into data frames, so that I can continue applying the functions of pandas on these data frames. So this data transformation that I have to do, I have to be aware of so that I do not have problems. Or that I continue playing with series, and then if my Python knowledge goes until then I can rather use series. So I will give you some time in order to have a look on this, but well, you have aggregation functions. Let's have a look to some particular ones. For example, I'm going to choose this one. This is a particular thing of Python. You will go to the previous ones in a minute by your own, but just let's have a look to this one. I am projecting the EDU table on value, and I am applying what we call a lambda function on the values of this column. In fact, Python is a functional language, which means that you can give as a parameter a function, a program, okay? So here I'm giving as parameter the program named D that computes the value of D to the power of 2. So when I will project the values of my table, these values are floating points. The function, this function will be applied to all the values of this column. And they will be transformed to the power of 2. Let's have a look at this. So those that have values have been transformed by this function, and those that are null values remain null. And then I can do many different things, project and then divide by the value and the max. Many of the functions that you would apply in order to transform your data or complete your null values. Then, as you remember from your relational knowledge, there's the data definition language and the data querying language. Now, in the definition language, you create the tables, etc., and then you can manipulate the data. And one way of manipulating the data is adding new records. So here I am adding a new record where the value of time is 2000, the value of value is 5, and the value of GEO is A. And I'm saying to ignore the index. In fact, what happens is every time I add a tuple, a record in my data frame, the system creates the new index, okay? And if I give explicitly the index, I might have a clash with an existing one. So with this, I am saying that it should ignore the index and create the index that corresponds by itself. And so you see, I have my new record here. Record and tuple are the same. So in the relational jargon, we would say tuple. And in the data science CSV jargon, we would say record. And again, you can copy values and add new, modify your content with many options that you will do through the, when you will in detail do this exercise. Then other possibilities are sorting your data, grouping the data, and rearranging the data. So you see, you can play with the organization of your data frame content in order. Why do you want to do this? Because you want to explore, okay? So by applying these kind of functions, you reorganize the data, you group the data, and you start having a vision of, a detailed vision of the content to determine the conditions in which you receive the data. In fact, what you're doing is determining the degree of rawness and the quality of the data that you are receiving in order to determine how you are going to complete, to modify, to clean, so that you can exploit it in further experiments. This is what you're doing with this. So you have possibilities to rank, to, as I said, I will give some time in order that you have a look to this. And then you can plot. Okay, so I have just to, in order to say, yes, I can start here. Look what we're going to do. We are going to drop all the records where you have dummy countries, okay? We want to have a pure version of our data collection with real countries of the European Union, okay? And then we are going to consider the case of Germany, and we are going to name Germany to territories that were identified as if FRG when Germany was divided into two states. So I want to have a first cleaning of this here. And what did I do? Yes, I have to go back to another. Yes. Here. I have to create my variable. This is what's going on. So I first created a table where I projected on time by the year. So I was interested in records after 2005. And then I transform my table into a table where I have the time, the years. I have the countries and the different values of the countries Okay. And now what I'm doing here is I am cleaning my data. So I have the same version of table, but without these cases. Okay. So I cleaned these dummy states. Then I am going to go further and I will filter Spain and Portugal. No bias with this. It's just an example. So we have the same case here, but only 2 years and 2 states. Okay. While I continue, I don't know what did I do, but anyway. I think that I went back at some point. I'm missing an instruction, but I don't know which one. But I'm not going to rename. I'm going to do it properly at some point. And then I want to solve the problem in a moment. Okay, this is not an important thing. It's just that I did some. Here I was filtering for Germany, but I don't know what I did. Anyway, I'm going to keep this idea, okay, that I have my times and my countries and a value for every year. And then what I'm doing here is I am pivoting the table so that I can have for every country its value. Okay. And now at the end, I'm going to have a little plot. Up. So what I have here is a plot that says the values that I have against the different countries that I have in my data collection. Okay, so it's a first plot and then a second plot. What I can do is plot in order to compare the different values. The values represent the educational level of the countries in Europe. So if you have a look, I have the level of education in every country that I kept. So I have no dummy countries anymore, and organized by year. So these are my years plotted in color. I have the levels of education, and then I have my organized by countries. And this just to understand the content. So it's a kind of way of profiling the content of my data, extracting dummy things, playing with the different countries, and playing with the different values in this case in order to have an understanding of the status of the data, its quality, and how does it look like in an aggregated manner, okay? No analytics here, okay? Just exploration. Thanks to these data frames. So what I will do is we're stopping at 12, no? Is that right? No, 12:30. Okay, so we have an hour to go. Okay, so what we will do is I will go to the next, so you will have time to finalize and have um, time in order to analyze this exercise, the next, so that I have time to introduce the wrap-up project that you have to do, okay? So, of course, I'm aware that I am giving just an overview of the tool and how it works, and that you need time in order to get acquainted with this. But during the preparation of the project, you will have this kind of time, and I will be there to coach you in this process. Okay, so for the time being, what we have done is we start with a raw format, we transform the data into tables, and we have a first observation on the content in order to identify null values, dummy values, and plot the values in order to have a first quantitative overview of the content. Okay. So now, there are, of course, other ways of starting analyzing data in a deeper manner. And this way is descriptive statistics, okay? So in the next exercise, what I want to introduce is the type of analysis that we can do playing just with these descriptive statistics, okay? And of course, show you how do we do it in on Python. I have a question. Wait. Yes, you can. You will get the video, but don't leave. Stay with us. Okay, so let's have a look to these descriptive statistics with the next exercise. Okay. I will put the link here. I always do this. I don't know why. Click and then I copy. So before we go on, questions, reactions.
When is the deadline for this assignment?
I don't know. I will. I have to think because I have to ask to my colleagues how they are scheduling the exercises, but I will announce this by the end of the day. Okay. You will see it's not. I mean, you need at most an hour to finish, not more than that. Okay. I was expecting to finish today with you. This is why I'm a little bit lost with the schedule, but you will have enough time, don't worry. And now, of course, I will make sure that this doesn't clash with the other activities that you have to do. Okay, so other questions? Is it the same? Yeah. Now, in order to this one, I will go with you in more detail. I will try to finish this with you because this is a more interpretation-like thing. Let's see how we do with this, okay? So what were the research question? Note that in the previous exercise, I was just introducing how to play with tables, and so there was no research question. So one of the questions that you should have asked, or at least you should have reacted, is, Madam, you are telling us that experiments are guided by a research question or a hypothesis, and here we do not have any, okay? So the reason is because I was introducing rather technical aspects of the data frames, but in fact we weren't really doing an experiment. Okay, so here we are going to do an experiment. So I need to introduce the research question. The research question is whether the advancement in careers, in professional careers, is guided by some point by gender, okay? Is it true that getting a decisional position in a professional life changes if you are a man or a woman, okay? So this is the research question. In order to answer it, we are going to use a data set, which is called the adult data set, that describes the sample of the US population, okay? And this data set includes the age of the people, of course, the gender, marital status, the county, not the country, and whether the person has achieved this decision-making position. And there is a huge hypothesis here, is that you are considered to have acquired this kind of position if your income is higher than $50,000 per year, okay? So, and there you have the reformulation of the question is, are men more likely to become high income professionals than women, considering that a high income is of more than $50,000 per year, okay? Now, this data is more messy than the previous one, because this data is of type of format .data. So we first have to process the data in order to produce a table-like format and then transform it to pandas, okay? So here we have this transformation process included in our experiment. As I said in the previous one, you can go to the data lab and have a look at the data. I prefer not to do that in detail because otherwise I won't be able to finish the exercise with you. So if you're curious, you can go and have a look on it. So we're going to open a file of type.data. So who knows what it is? And we are saying that it is on read mode, okay? This is what we're saying here. Yes, I forgot that I am going to, what am I going to do? Well, I'm going to continue here. What you have to do is create a new notebook. Now let's create a new notebook. So in order to create a new notebook, you can go to the notebooks, and I'm going to show you another way of associating data. So go to kaggle.com, you click on notebooks, the left side of the page, and then you have this new notebook button in black. So you click on there and you wait some seconds. Well, I wait some seconds because I'm having connection problems. And here in the right side of the page, you have add data. So you click there, and there you have many options. You click on your data sets because that is the one that we are going to use, the one that we created. Then I named my data set EGI data. So choose the one that you created for this, this session, and you click on Add. And you see you have, it's preparing to download. And now I have it associated here. You run this first piece of code. Remember that it imports the two libraries and then it gives you the the paths of your files. And you see, this is the one that we are going to use. I'm going to close this, keep this. So finally, I'm going to open my file. And as I said before, I have to complete it with the right path. So I open my file, nothing happens. This is normal because I just opened the file. And then have a look on this. What I'm doing is I go through, in fact, it's there are records inside, but the records are not CSVs. They are just elements divided by commas. And I'm going to create a table with all the elements of each record, okay? So I have 14 columns, which are the 14. I went through the data and I saw that every record has 14 elements divided by comma and then a return. And again, 15 and divided and return, like that. So this is why I built this piece of code that reads every record, goes element by element until it finds a comma, and then it creates a column. And I store it in the variable data. So it's a kind of list of elements. And then I have to print my result, or I want to see it. So I'm saying that I want to print the content of my data. You see, so I'm just printing an element of what I did here. And I have here my 14 elements, all divided by comma. You see? And I have like this many. I just selected one, okay? And now, once I have this data structure with these records that I built artificially, now I'm going to use this in order to create a real data frame, okay? So this import we have already done, so this is not, we should not do it. If we do it, there's no problem. So I'm going to define a data frame with the content of this data structure that I have created. And then I am going to name the columns, okay? Note that here I am doing this in 2 steps. In the previous exercise, I did everything in 1 step, and here I am first creating the data frame, and then I am naming the columns, okay? And then I am observing the head. But this you already know, because in the previous exercise, we know how to observe the head of a data frame. Now we have a huge thing. Now that here you have the scroll to see all the attributes that we have created. So you see, we did a first processing of the data in order to format it, and that we can have a more comfortable access to it. And then, of course, we can do that. This is interesting. So here we observe the tail, but this is interesting to see. So if we ask for the shape, what it gives is the number of records and the number of columns. So we have 32,5K more or less records and 15 columns, which we already knew because these were the columns that we created here. So let's start understanding. For example, we can, since we know that here is county, it's not country, we name it country, but it's a county. So we want to know what happens with respect to the different regions of the data. No. Oh no, and we have also countries, yes. So have a look. Per country, we have different amounts of data. We have, we have an unknown country with many data. We have, for example, Cambodia with only 19 records. We have Germany with 137. We have India with 100. Okay, why do we need this? And the United States with a lot. Because we want to know how representative the data as per country are contained in our data collection. Because if we want to conclude, to answer the research question, whether women develop their professional careers better or not as good as men in the different countries, we need to have representative observations of the countries. So if we have one observation, it is nonsense to try to do some analysis on this data, okay, on these pieces of the data. Same thing, for example, we can reason by age. And then see what happens, what about age? So if you have a look, for example, very young people, we have this number of observations, people that normally should be economically active. We have this amount of observations, and then again, people that are reaching the 80s might not be very interesting for our analysis, because we normally at that age in some countries, people are not economically active. So, but since we are interested in male and female analysis, in gender analysis, what we're going to do first, of course, this is a possible experiment, okay? So you can contest the way we reasoned in order to implement it. It's just an example on how we design an experiment in order to answer the research question, okay? So here what we did is we did two observations. First of all, we wanted to observe male professionals in general and male professionals that already have the income that we had as a hypothesis as a high income. Okay, and we want to see how many of them do we have. All countries confused, okay, included. I should have split it in two. This again. So in general, men act in the data collection. We have 21K and something, almost 22K records, okay? And male with high income, let's see how much observations do we have. Well, there are much less, no? We have 6K and a half of male professionals in the data collection with an income higher than 50K. So there, initially, despite gender, we already know that very few observations are concern high income professionals. So let's have a look on the female cases. So a first observation. Note that in general, observations concerning male professionals are this size, 21 and almost 22K, whereas female professionals are 10K and a half, no? Well, let's say 11K. So almost here, sorry, we have a problem. And the question is, do we have this unbalanced number because we didn't observe enough female professionals? Or is it because from the beginning, there are much less female professionals, okay, female active, economically active professionals, okay? So that's the first question to be discussed in this experiment, okay? And now let's have a look on these few female professionals, how many of them are high income professionals. Well, 10% more or less, no? Less than 10%. Yeah, much less. Okay, and again, well, this is natural, no? Because we already have very few, much more male professionals than females. So of course, the number of high income female professionals is less. But we have to think now about proportions, no? In order, given that the balance is not there. So let's think about proportions. So the rate of people with high income in general, both men and women, is 24% of the observations. The rate of men with high income is 30%, and the rate of women with high income is 10%. Okay, so this is a more reasonable comparison with respect to this balance, no, or gap. In fact, what we're measuring is the gap. And so we can, for example, now have a first summary of the analysis and give this conclusion, no? Which is the previous one. And now, we can go further in the analysis. Here we have the rate, but we could start playing with statistical measures and try to see how does this gap look if we apply the mean, okay, in terms of age. Because remember, the idea is how long does it take for a professional to be a high income professional, depending on the gender. So first of all, what we have a look is on the age in general. This is the kind of reasoning that we applied throughout the experiment. So the average age of men is 39, and the average age of women in our observations is 36 and almost 37. No? Now let's have a look with respect to income, to high income. Remember that high income is in the variable M1, okay? So we are keeping these contents in order to continue playing with our observations. Well, they're not very far, you see. So high income female professionals are 42, and high income male professionals are for almost 45. No? And then again, you see, this is interesting. Can we really conclude that female professionals get to have a high income before men? Or is this just an illusion? Now we can use the notion of variance in order to continue analyzing these differences, and then compute the standard deviation in order to do our comparison, okay? So here we are computing the mean, the variance, and then the standard deviation of men and women collections, and here is the summary of these values. You see, so we have these variables there you have to interpret. And then we go further in the analysis and well, here we reason per age, and here we are reasoning per hours of work per week, which is very interesting in the case of the comparison between, I mean, when we adopt a gender criterion, and then start understanding whether, for example, this difference in the moment in which you reach high income uh, regards the number of hours per week that you're working, regards what happens with respect to the age, and so on and so forth. Okay, so this is the same reasoning that, or more or less the same reasoning that we do applying the median of age of hours per week of age of female and male professionals, and then the hours per week. And then what happens is that we go further in the reasoning and we start organizing the data per quartiles in order to have a deeper understanding on these observations, okay? And what is interesting is that here we start applying visual plotting in order to have a better understanding on the problem. Okay, so this I'm not going to do with you. I am going to let you continue with these observations. You will see that we are doing this. We are then playing with data distributions, completing with plotting. Then an interesting aspect is that in no case we considered outliers. Okay, so we complete the analysis this time by dealing with outliers in order to have a finer tuning on the analysis. So this concerns another part of the experiment. Then we measure asymmetry, relative risk. So all these statistical concepts that we have learned and that we apply here in order to answer the research question. And we also observe the distributions, which are very important. We remind the central limit theorem that you all know and that has a role to play in the analysis. And at the very end, we wrap up all this together in order to have a conclusion and answer the question. So again, what will happen is that I will let you go through it. You will see that, I mean, the knowledge is the knowledge that you have from statistics. It's just, we show how to use Python in order to apply this, and show that even with this general mathematical knowledge, we can already perform and design an experiment and already give all the arguments necessary in order to answer the research question, okay? Again, note that the purpose of these exercises are more to show you Kaggle and the fact that you can use these kind of tools that are ready to use in order to concentrate on your experiments, and that the further parts of the lecture will really go and dig into the design of the experiments and not on the tools, okay? So this is more tool oriented, and the next part will be more experiment oriented, where you will have space to creativity in order to address problems related to your discipline. Now, in the last minutes that I have, well, first of all, I open the floor for questions. My computer is playing some weird things. I'm sure that, I suppose that you are listening, otherwise you should have raised your hand, but well, anyway. Okay, so first I open the floor to questions before I use the last minutes of that we have in order to introduce you with the wrap-up project that I am proposing, and then determine an appropriate schedule so that you can go through the exercises and through the wrap-up project and hand in your work correctly. Anyway, I'm sure that the questions will come up when you will touch on the code and on the exercises. Remember that all questions regarding my part can be answered on Slack. I'm almost always available on Slack, so at any point you have questions, you can use this channel in order to ask and share with the others. Okay, so I know that sometimes you need to interact with me privately, but if you have general questions, prefer the general channel, because sometimes the question concerns many people, and so it's useful to share your know-how or your questions with the others and the answers, so that we create a constructive community for addressing these problems. Okay, so I'll just have a look on Slack. Okay, apparently I don't have questions. So let's have a look to the wrap-up project. So just to wrap up this part, so we did this introduction to Kaggle. We configured our environment by creating a data collection on the data lab of Kaggle. Then we learned how to create notebooks, associate data with the notebooks, and then we got acquainted with the data frame, with the pandas library, in order to deal with tabular data, to manipulate tabular data. And then we used an example of descriptive statistics in order to have a first touch on an experiment developed in order to answer a research question. Okay, so this is what we have done in this morning. Now, traversal project. I moved by this thing comes here. The idea of the project, it's a wrap-up project, is to show how to integrate what we have done in Mongo with Kaggle and with data analytics. Okay, so this is the intention of this wrap-up project. You have the description here in the Google Classroom. I am going to open it in this PDF. Just to explain. Well, as I said, questions on Slack all the time. Then what do we need? Since I have seen that some of you have problems with connecting with the MongoDB server on the one side, and on the other side, you always need a VPN in order to connect to that server. Yet in Kaggle, you are not connected on the VPN. And so you cannot contact through a notebook, the NCMAC server. So I figured out an alternative solution so that you do not have to use the VPN and that you can still contact Mongo from a notebook, okay? No longer shell to be used, it's through the notebook that you are going to get the data and query them, okay? So in this sense, we will be using a support, a public support that lets you manage clusters in Mongo online, Mongo clusters online, more or less as the one we configured for the exercise, but this time this cluster lives for a long time. Okay, so it doesn't disappear after 4 hours, it is there running. Okay, so this is the Atlas MongoDB cluster solution. We will be using this. I have already one running for you. Then we are going to use a data set that you will eventually use in other moments of the course, which concern, I will explain in a moment, the trips that people do in a city. We are going to use Kaggle, and I have prepared an initial notebook on Kaggle so that you can start from it and then develop the exercise, the project. It's a very little project, very simple one. Okay, so the objective is to get acquainted to a data set by retrieving, querying, quantitatively exploring its content using descriptive analytics. So the idea is that you are going to generate statistical observations, more or less as the first exercise we performed today, in order to understand the content of the data collection. Okay, this is the objective. So in order to do that, you are going to design an experiment and implement it on a Python notebook on Kaggle. And inside there, you will plot the content of the data stored in Mongo Atlas cluster. So in order to explore this data, you will include, the initial queries are already given in the notebook. You will include MongoDB queries, like the ones you have done for the first hands-on to explore the collection. And then you will retrieve your data as we did today, and then starting doing statistics and plotting the values and the distributions and all these things, okay? You will use markdown cells in order to annotate all the operations that you do in your experiment, explaining the objective and purpose of the operation that you do, and then interpreting the results that you obtain. Okay, this in markdown cells. And at the very end, you will, with a separate tool that you will include then in your notebook, you will have to draw the architecture that shows the different components that you are using in order to build your project. Remember that my part concerns also architectural aspects, so it is very important that you understand the different pieces of architecture that we are using in order to compose our notebooks. Okay, so as the behind the scenes figures that I have prepared for you in order to introduce the exercises, there's a similar one for this behind of the scenes of the wrap-up project. So you will you will share the Kaggle notebook that you will implement with me. And in particular, these results are due to the first week of December. Okay. Now, with regards to the data collection, the data are used from an extraction of the movements of the trips of Grenoble residents in 2010. They describe trips made by members of households in Grenoble. They provided data on individual and household characteristics with many different attributes. So as today that we have to explore the different attributes, you see the same type of exercise that you will apply for this data collection. And the data collection in Mongo is stored in a database called GREMD, and it has 3 documents collections. The names are here. Now, with regards to the cluster of Mongo, it looks like this. Okay, so you can have a look at if you are curious, you don't have to do anything. It's just to explain what is behind. So instead of having NCMAG and MongoDB on NCMAG contacted by us, you will contact this cluster. It's just the same thing. So the idea of Atlas is that you are going to have distributed Mongos on the net. And now, well, the one that we are using is BDEGI. That's the one that I created. And it has 3 shards. Now you know, because you have played with shards. So you have 3 shards, and the cluster provides you with information on the collections stored there and different details, okay? But the important thing is that you have 3 shards and that you access from where? From the primary shard, okay? So it's the same thing that we have done, just to wrap up all this part, okay? So just to give you a look on I had it somewhere. Yes, I have many notebooks. So at some point I have this one. No, I'm going to click. Yes, this one. Otherwise, I'm going to click on my link. Just to let you see the initial notebook. How does it look like? I don't know why I'm having connection problem, so it takes a little time to. Let's see if I click here whether it's less time consuming. Yes, it is. Okay. So the notebook, the initial notebook that we are providing to you looks like this. So, well, this is an installation of a library that you need in order to play with a cluster. Then you import different libraries. You import particularly a library that lets you interact with Mongo from the notebook. And then just have a look. It's thanks to this library that I can execute this. So I'm contacting a Mongo client, it's like contacting the CLI that we used in the hands-on number 2. So this is the address of the CLI that gives access to the cluster on Atlas. Okay, and then we test because we like testing. Once we are connected, we have a client connected to the Atlas server. It's just as you connected to the NCMAC, but this time you are connecting to this Atlas cluster. Then you can explore as usual. You can obtain a database. You can obtain within the database that you already have connected here. You can have access to the different collections of the database. You can list the names of the collections. So we have the 4 collections that compose our the data that you will be using. Using the one of the collections, this one you know already, you can select all the content of the data collection and so on and so forth. Okay, so these are the type of queries that you already are acquainted with by using Mongo, but just done, given in the notebook. Okay, so out of these, the idea is that you query all the 4 data collections so that you can see how they look like, the type of data that they have. And once you have retrieved them to the notebook, then you can transform them, for example, to data frames, and then start applying these descriptive statistics operations on them in order to give the quantitative profile of these data collections. Okay, so this is the spirit of the exercise. Now, what I suggest is that, for example, until, I don't know, Monday of the next week, you connect on Slack and you make sure that the first part you can do, okay? If you have questions, then you ask me on Slack and we can go eventually together in order to have the first part done. And then the second, and so on and so forth, so that I can coach you in the development of your project, but that you can still do by your own the solution. The deadlines are not marked on marble, okay? So if I see that many people are very charged because you haven't finished the first one, the other exercises, and so on and so forth, we can revisit the deadlines. Do not be worried about this. Okay, so now the floor is open in the 9 minutes that we have to ask questions, to react, to chat.
I have one question.
Yes.
Should we run all the chunks before to begin writing and doing the questions?
In this project, do you mean?
Yes.
Here, the chunks are transparent to you. You are just querying the MongoDB as you did in the first exercise. You just connect to the server. Now you know that it's a cluster, but in fact, this is transparent to you. And then you perform your queries as usual in the Mongo language. You don't have to be aware of whether there are many chunks or not. You know that there are chunks, but from the notebook, you do not care about this.
Okay, thank you.
Mm-hmm. More questions? Just let me have a look on how many people are connected on Slack, because I have the suspicion that not all of you want to use this one. So I have 30 people. Oh, okay. Now I have 31 people connected. Okay. So I think that you are 31, 37. I don't remember, but I just make sure that you are really connected to Slack and try to regularly visit the channel, because some people are active and they ask questions, you know, so there you can have a vivid interaction with you and your classmates. That's a good question, Lulico. You can decide whether to work with a group. It's in the same case as in the other exercises. Up at most 4 people in the groups. If you decide to work in group, and you can also decide to work alone. This is up to you. Just as I said, when you prepare your notebook, at the beginning, you put a mark down and you say the authors, and then I will know that you have worked in team or not. Okay? So I have the same question, so I think I answered. What else? Well, if there are no further questions, I want to thank you for your attention, for your assiduity. I wish you luck in the projects, but particularly in the master. Luck, and I'm sure that you will have a successful professional experience during the master and afterwards. So stay safe and let's keep in touch on Slack. Thank you very much.
Thank you.
Thank you. Goodbye.
Thank you.
Bye.
Stay safe. Bye-bye.